Hello and welcome to Olathe West ACT. My name is Mr. Flynn and we're going to be doing ACT math portion, specifically probability. So in today's lesson, we're going to be dealing with probability. And what you'll probably need to do, we're going to spend 2 days on this. What you'll most likely need to do is to download the PDF document for today. Now, let me show you how to go about doing that. Everyone here has been able to get to our YouTube channel. Make sure when you've gotten there, you have subscribed. Again, the way to get to this place is you go to YouTube, log in with your account, and then search for Olathe West ACT. Comes up, you want to subscribe to it. Now, here's where you can find the materials. We click right here on the banner, click here for ACT materials. And for us, it's going to be mathematics. This will be the same for everything, right? This is where you're going to go to get your stuff. But I will open up mathematics, and probability is the one you want to open up, okay? So go ahead and do that now. Give you, about a minute to go ahead and get that together. Okay, well, let's begin. Okay, so the way I'm going to work this is the ACT math section there's a lot of math in there. And so we're going to cover topics right now, and then we're going to get into the process of doing some practice testing, some timing, and so on. But we need to get some materials down first. Probability, you're going to expect to see 5, maybe 6 questions dealing with probability. So we should spend some time on this. There's only 60 questions, right? So probability, we're going to start with the basic one. I know this is like question number 2, right? Whenever I read a question, and the ACT's got a lot of reading in here, I always recopy the information. So we have 2 $5 bills. So $5. Sorry. So for $5 bills, there's 2 of them. For $10 bills, there are 9 of those. And there are 5 $20 bills. Question says, what is a probability that the bill drawn from the wallet will be a $20 bill? Well, probability is always defined as favorable over the total amount. So in this wallet, how many bills are there? Well, there's 2 5s, 9 10s, and 5 20s. That's a total of 16 bills. So the probability of getting a $20 bill, 16 would be in the denominator. Now, favorable. How many different $20 bills are there? Well, there's 5 of them. So the answer should be 5 over 16. That would be letter J. Okay, not too bad of a start. Let's go ahead and I want you to do the next question. It's another one, but it's a different format. It's just like what we did. They want to know what is the probability that a student selected in random from the class on Thursday is in group number 4. So here's a table. Got to kind of go about it. I'm going to give you 30 seconds. All right, so there were 8 people from group 1, 12 from group 2, 6 from group 3, 2 from group 4. Now that's a total of 28, right? Now do we want to know what's the probability that you're going to be picked from group 4? Well, group 4, there are 2 people there, so the answer would be 2 over 28. Now I look at my answers, I don't see that. But 2 over 28 does reduce to be 1 over 14. And that, my friends, is the answer. Okay. Now, The big thing with the ACT math section is they really like to repeat some questions. Here are two questions from different years of the ACT. Notice, very similar. As we practice more and more ACT questions, you're going to start to recognize questions like, oh, wait a minute, we've seen one like this before. That makes things a lot easier. So whenever I see something like this, I ignore all of this and I go right to here. What is the probability that a randomly selected chip from this batch of 100 is type 1 and manufactured by company B? So we've got to look at this table. Well, here's type 1, manufactured by company B. Well, there's 30 of them, right? So the probability would be 30 over, now, how many total batches are there? If I look at this, it tells me there's 100. I could get that also by adding up 4 numbers here, but it's quicker just to look to see 100. Now, before we do reducing or anything, we should look at the answer key and see, do we see 30 over 100? Yes, we do. So that tells you a couple things. ACT, sometimes you don't need to reduce the fractions. When you get an answer, look and see if you see it. I hate to have you do extra math that you don't need to do. Okay. I want you all to do this next question, question 11. It's just like this one. I'm going to give you 30 seconds. Okay, they want to know what is the probability that they ordered a regular coffee without milk. So I need to find that. Well, here's regular coffee, here's without milk. That's the number, 10. There were 10 people that did that. Now, we have to look and see, well, how many customers were there? Shows it to us 2 ways. First, they say here, 36 customers were there. Also, right here, there were a total of 36 customers. So either way, so the answer should be 10 over 36. Now, if I glance at the answers, I don't see it there. So this one's going to ask us to reduce. And that reduces to be 5 over 18. And we see that is letter B. Okay, these are just kind of our introductory math questions for probability. Now, there's a concept here on question 6. Now, again, remember, when you're reading, you always want to write down the information because it makes it easier to figure out the problem. They tell us that a bag has 18 buttons. There are 3 red. So I'm going to say 3 red. There are 5 blue. And there are 10 white marbles. Okay. They want to know what is the probability of randomly selecting one button that is not white. So this word not white. Well, if we're not going to pick the white button, that means we have to pick a red or a blue one. Well, how many of those are there? There's 8 of them out of a total of how many buttons were there? 18. So it should be 8 over 18. If I look, don't see that answer, but that does reduce to be 4/9, which is letter H. Okay, not too bad. Sometimes ACT gives it to us graphically. So let's look at this one. Here's a graph. It's drawn to scale. And it's a dartboard. And they tell us something here that the sectors red, white, blue, and green, whose areas are in a ratio of 1 to 2 to 4. That now respectively means these go together. Like 4 is the last number and green was the last thing said. So green is 4 times big. Blue was the second to last number that corresponds to 3, which is the second last number. Blue is 3 times big, so on. I'm going to put those numbers in. 1, 2, 3, 4. Again, just translating from English into some math. Now, Brad's going to throw a dart at the dartboard. Now, we're pretending Brad can't see the dartboard. He's throwing it randomly. He's not aiming. He's just throwing it. They want to know what is the probability that the sector the dart hits is not the blue sector. So we are not hitting blue. That means we're going to hit green, red, or white? Well, total of that is 7 out of how many? 10, right? If we add those up, 7 over 10, letter E. Not too bad. Okay, so those are like our introductory type of probability questions. Now, let's get a little bit more interesting here. So this one. Now, it's question number 2, and I found on another test one very similar to it, right? They're changing it from history club to French club. We're going to do this one together, and then I'm going to have you do this one. Again, the more ACT math questions we practice, the more things that you'll see that are similar. We have 35 people. The members decide that representative who will be chosen at random cannot be the 3 officers. So they're not going to have the president, vice president, and treasurer be the representative for the club. They want someone else to do it. So this says, what is the probability that Hikaru, who is a member of the club but not an officer, will be selected? Now, here's the mistake that some people think. Okay, 35 people. There's only one way to pick Hikaru. That would not be correct. That's meaning all 35 people they're going to choose from. Didn't they say cannot be one of the, and no, do you notice 1 over 35 is an answer? They try to find all the mistakes you can make and have them in there. We are not going to be one of the 3 officers. So there's not really 35 people they're choosing from. They're really choosing 35 minus 3, right? Because there's going to be 3 less. Of course, there's only one way to pick our man. So the answer would be 1 over 32, which is K. By far in this one, the common one people pick is letter H. Be careful, all right? Now, I want you all to do this one. I'm going to give you 30 seconds. You may begin. Okay, we are told as a 32-member club, they're going to choose a representative who will be chosen at random, cannot be one of the, there's 5 officers for the French club. So when I think about how many possibilities are there, there's not really 32 people they're choosing from. They're choosing 32 minus 5, right? Because they're not going to be picking one of the 5 officers. And could Louis be picked? Well, it'd be 1 over, right? There's only one way to pick Louis. And so this would be equal to 1 over 27, which is letter C. Okay, picking clubs, not too bad. Again, notice those were like question 1 and 2 on the ACT, right? If you haven't done any probability, this would be a difficult question. But now that you've done it, it shouldn't be that difficult. Let's continue. Question number 5 from one test and question 7 from another. Very similar. Now, we're going to do this one together, and then I'm going to have you do this one. Certain committee is composed of 9 juniors and 11 seniors, right there, 11 seniors. We've got 9 juniors and 11 seniors. Okay. Now, 2 different members of the committee will be chosen at random for 2 different leadership positions. Given that the first member who will be selected is a senior, so the first person they're picking is a senior. They've already picked someone, it's a senior. What's the probability that the second member will be chosen is a junior? Well, right now there's 20 people in the club, right? We're trying to figure out what's the probability of picking a junior if they've already picked a senior? Well, if they've already picked someone, there's not going to be 20 people, are there? There's only going to be 19 to choose from because they've picked someone to go first. Well, probability you're a junior, there's 9 juniors. So 9 over 19. There we go. All right, 30 seconds. You all do this one. All right. As you were reading, you should have made a note that there were 8 juniors and 4 seniors. And they're saying, given that the first student selected as a junior, so they've picked a junior first, what's the probability that the second person will be a senior? Well, there's 12 people here, but again, they've already picked someone. So there's really only 11 choices out there, right? Because they've picked the first person. Probability of picking a senior, well, there's 4 seniors, so it's 4 over 11, choice E. Okay. This is like this conditional probability we talk about. All right, now let's look at one. It's not bad. I know it's number 50, and you're like, oh my gosh, number 50. That's like the last 10 questions. Those are supposed to be tough. This one's not bad. It really isn't. So let's read the setup, and then I'm going to show you how to figure out the probability. It says, Tom is in Miss Zhu's class. To choose 4 students from her class of 24. Okay, so there's 24 students in class, and she's picking 4 of them. All right. Ms. Zhu will put 24 cards, each with the name of a different student of her class in a box. And then she randomly pulls 4 cards out of the box. And it says without replacing. So that means, let's say they pull Tom out of the box. They're not going to put Tom's card back in and pull it out again. He's already out of the box. He's going to stay out of the box. That's what it means without replacing. We're going to keep the ones that we pull out. Question says, what's a probability that Tom's card will not be drawn? So what's the probability of not picking Tom? Well, she's picking 4 cards out. So this is our first bit. We're actually going to be multiplying 4 different probabilities because she's picking 4 separate cards. Now, we don't want Tom's card to be picked in any of these. So when she first goes to pick a card out, there's 24 students in there. How many of them are not Tom? Well, 23 of them are definitely not Tom's card, right? There's only 1 Tom, so there's 23 that are not. Now, she doesn't put the card back. She pulls out another card. Well, since we've picked the card out, now there's only 23 cards left to pick from. How many of those are not Tom's? Well, 22 of them are not Tom. Then she pulls another card out. We've pulled 2 cards out already, so there's only 22 cards now available. Of those, 21 are not Tom. Well, we've picked 3 cards. The 4th card, how many possibilities? Well, there's 21 cards in there. How many of those are not going to be Tom? 20 of them. Now we got to multiply these. We could use our calculator and multiply this, but I think you'll see that some nice canceling happens here. And when we multiply across, we get 20 over 24, which I don't see in the answer choices, but that does reduce to be 5 over 6, which is right there. Okay, so that's our introduction one. Now let's move on to some more complicated probabilities. The first one being this idea, probability of A and B, probability of 2 things happening. Like it would be like probability of flipping a coin and getting heads, and then maybe spinning a spinner and getting to number 5. Probability of 2 things happening. We just did this. You multiply the 2 probabilities. We just did that on the previous question, right? We found the probability of each of those pieces and we multiplied them. So let's look at this one. And this deals with days and months. It says 1 day will be randomly selected from the 7 days of the week, and then 1 month will be randomly selected from the 12 months of the year. What's the probability that the selected day will be Tuesday and January? So what's the probability of picking Tuesday and January? Well, that would be the probability of Tuesday multiplied by probability of January. Well, for Tuesday, there's 1 day out of 7, right? For January, there's 1 month out of 12. We multiply those across, we wind up with 1 over 84, which is choice F. Definitely not too likely of happening. Okay, let's look at another one. Now that's number 24, not too bad. This one's 26. I'd like you to kind of try this one out. want to give you 30 seconds and try it. Okay, they want to know the probability that an 8 is rolled both times. So the probability of an 8 and rolling an 8. Well, that would be the probability of 8 times probability of 8. Well, we're told it's a 8-sided game piece with faces numbered from 1 to 8. So it's not like a trick die where like maybe half the numbers are 1 and the other half of the numbers are 2. Every side has a number 1 through 8. Well, the probability of rolling an 8, well, there's 8 different sides and there's only one side with an 8 on it. Same thing here. Multiply across, 1/64, choice F. Okay. Now, there is a good technique on the math section of the ACT. It's called glance at the answers. We should not progress doing this question yet until we glance at the answers. Notice the answers here are kind of like what our setup was on the previous problem. So we should keep that in mind. It might help us what's going on. And again, if we read along, we can see that there are 3 red marbles. So 3 red, 2 green, 1 yellow, and 4 blue. Which of the following expressions gives the probability of drawing at random without replacement a blue marble? So you want to know the probability of a blue marble on the first draw, a green marble on the second, and a blue marble on the third. Blue. Okay, now notice we're doing without replacement. I want to give you 30 seconds to think about it. Remember, ACT tries to find the mistakes you can make and puts them in there for you. Okay. Now the total is 10 marbles, right? The probability of a blue marble, it's right here, it's 4 out of 10. I look at all these answers, they all start off with 4 out of 10. So, well, that's good. Probability of a green marble, well, there are 2 green marbles, but remember, they did this without replacement, right? They're not putting the marbles back. So there's no longer 10 marbles available. There's only 9. So it's 4/10 times 2 9ths. Notice part A, 4/10 and 2/10. Yeah, that's not it. Same thing with B, 2/10. Nope, looking for 2 9ths. So it's going to be either C or D. Now, probability of a blue, there's only 8 marbles left. And of the blue, we've already picked a blue marble, right? So instead of being 4 blue marbles, there's now 3 blue marbles. This is the choice, letter D. Okay, next week, we're going to continue with probability. Thank you very much. Been a great audience.